write down. Concept. Very, very important concept. Concept. Number of ways. Concept. Number of ways of writing a number. Number of ways of writing a number. Very important, sir. Next half an hour, pay attention. Number of ways of writing a number. Number of ways of writing a number as a product of two factors. As a product of two factors. This is an extremely important concept. Number of ways of writing a number as a product of two factors. There are two cases. Case number one. First, we will discuss the theory today. Problems we will discuss in tomorrow's class. Tomorrow also we have got a class from 11 to 1 p.m. and 5 to 7 p.m. 11 to 1 p.m. and 5 to 7 p.m. Every day. For about till Sunday, I will take 4 hours of classes every day so that a student will learn as many concepts as possible. Now see here. Number of ways of writing a number as a product of two factors. Case 1. Case 1, it is an ordered pair. Case 1, it is an ordered pair. Ordered pair. Ordered pair. When this case 1 is used, if the variables are present in the question, if the variables are present in the question, if the variables are present in the question, make use of ordered pair. Make use of ordered pair. Ordered pair. Order in which you write matters. A and B. In A and B, A is written first. In B and A, B is written first. So the reverse is not equal. A and B is not equivalent to B and A. A and B is not equivalent to B and A. Please read the question. Number of ways of writing a number as a product of two factors. Number of ways of writing a number as a product of two factors. Suppose 12 it is there. 12, how many ways you can write? 1 into 12, 2 into 6, 3 into 4. Reverse it is also can be written. Order matters. Here writing 1, then writing 12. Here writing 12, then 1. Reverse also it is possible. 6 into 12 and 6 into 2 and 4 into 3. Any other ways are there? There is no other way. 12 factors are 1, 2, 3, 4, 6, 12. All of them we got. So 12. 12 can be written as a power of prime bases. 2 square into 3 power 1. How many factors are there for this number? 2 power 0, 2 power 1, 2 power 2. 3 power 0, 3 power 1. This is one factor. 2 power 0 into 3 power 0. 3 into 1. This is another factor. Another factor. Another factor. Every power of 2 is combined with every power of 3 to get total factors. 0 to 2, there are 3 factors. 0 to 1, there are 2 factors. 2 power 0 into 3 power 0, 1 factor, 1. 2 power 0 into 3 power 1, another factor. This is another factor. 0 to 2, 3 factors. 0 to 1, 2 factors. Totally 6 factors are there. How many ways we got? This is one way. This is second way. This is third way. This is fourth way. This is fifth way. This sixth way. Total 6 factors we got. Please write down this important point. Number of ways of writing a number as a product of 2 factors. It is nothing but equivalent to number of factors. Where it is a number of factors, it is equivalent to number of factors in an ordered pair. When to use an ordered pair? We will use an ordered pair if the variables are present in the question. If the variables are not present in the question, then we will use unordered pair. If the question contains variables, use ordered pair. Ordered pair, as the name suggests, A comma B is a pair. Order matters. First writing A, then writing B. First writing B, then writing A. Both are different. Order matters. Order matters. I hope it is clear, right? I hope it is clear. Order matters. In modern mathematics, it is simple, nothing but NCR. Unordered pair, it is nothing but NPR. Both are same language. In math number system terminology, I am writing it as ordered pair. Ordered pair. Ordered pair means if the variables are present in the question, make use of ordered pair. Ordered pair. Ordering matters. How to find out the factors? Write the number as a power of prime basis. Take 0 to the highest power. 0 to 2, 0 to 1, 3 into 2, 6 combinations. 3 into 2, 6 combinations. I hope the idea it is clear. Now we will take up a question. Take up a question. All these questions. 1 minute, sir. Questions we will take. All are very, very good questions. Not a single doubt you will get in my class. X into Y equivalent to 100. X into Y equivalent to 100. X and Y are natural numbers. X and Y are natural numbers. How many values X and Y will take which satisfies these equation? X into Y equivalent to 100. X and Y are natural numbers. How many values it will take which satisfies these equation? Solution. Step by step we will discuss. Are the variables present in the question? Yes. If the variables are present in the question, which pair it will be? It will be ordered pair. In ordered pair, what will be the answer for the question? Answer for the question is nothing but number of factors. Number of factors. How to find out the number of factors? 100 is nothing but 4 into 25. 4 and 25 are composite. Write down it as a power of prime basis. 2 square into 5 square. So 0 to 2. How many combinations? 3 combinations. 0 to 2. 0 to 2. How many combinations? 3 combinations. 3 into 3. In how many values xy will take which will satisfy this equation? Number of factors will be 9. Number of factors will be 9. In case if you want to do 1 into 100 is one way. 100 into 1, it is another way. You don't need to do it. Just for conceptual clarity, I am doing. 2 into 50, one way. 50 into 2, another way. 4 into 25, one way. 25 into 4, another way. 5 into 20, one way. 20 into 5, another way. 10 into 10, another way. Total, how many ways you got? Please check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the answer you got? 9. Please make a note of it. Number of ways of writing a number. Number of ways of writing a number as a product of two factors. As a product of two factors, it is nothing but number of factors. It is nothing but number of factors. It is nothing but number of factors. I hope the idea it is clear. Second question. Directly we will write down x into y equivalent to 2 power 7 into 3 power 4 into 5 cube. xy are natural numbers. xy are natural numbers. How many values xy will satisfy these equation? How many values xy will satisfy these equation? Directly 0 to 7, answer is 8. 0 to 4, answer is 5. 0 to 3, it is 4. 8 5s are 40. 44s are 160. Answer for this question is 160. Answer for this question is 160. Third, I will change the question. X into y equivalent to. If the variables are present in the question, then it is an ordered pair. X into y equivalent to 360. X and y are integers. X and y are integers. Now I changed the question from a natural numbers to an integers. How many values xy will take which satisfies these equation? X into y equivalent to 360. X and y are integers. How many values xy will take which will satisfy these equation? 360 is nothing but 72 into 5. Write down it as a power of prime bases. 2 cube into 3 square into 5 power 1. 2 cube into 3 square into 5 power 1. Right. Integers means both the cases I will get. Positive, right? Plus into plus is positive into positive is positive. Negative into negative is also positive. Two cases. If two numbers product is positive, both of them can be positive or both of them can be negative. So how many factors will be there? 4 into 3 into 2, which is 24. 24 positive into positive, 24 negative into negative. So either it can be positive into positive or negative into negative. 24 plus 24. What will be the answer? 48. Answer for this question will be 48. Why it is 48? Why? Because like the way you write 1 into 360. 1 into 360. Next it is 360 into 1. This can also be written as minus 1 into minus 360. And it can also be written as minus 360 into minus 1. For this case 24 I will get. This case 24 I will get. 24 plus 24. What will be the answer? 48. Please see the difference between these two questions. It is x and y are natural numbers. Natural numbers are the numbers which can be counted. Positive into positive, it is positive. X and y are integers. Positive into positive, it is positive. Negative into negative, it is also positive. Write down these, put a star mark on the second question as well as on the third question. Right? These second question star mark and third question star mark. One is x and y are natural numbers, x and y are integers. Suppose a student says, sir, what if x and y are rational numbers? Rational numbers means so many cases can come. Denominator can be a factor of y. Denominator of y can be a factor of x. It will result in countably infinite. It will result in countably infinite. I hope these three questions are clear. What is the important learning? Ordered pair. What do you mean by an ordered pair? If the variables are present in the question, make use of ordered pair. If the variables are present in the question, it is an ordered pair. Ordered pair. In a pair, the way in which you wrote the variables matters. Ordered pair. So case 1, I hope it is crystal clear to you. Crystal clear to you. When we are solving variables in algebra, it is of extreme importance to check whether it is an ordered pair or an unordered pair. Case 1, I hope it is over. Case 1. Case 2. Number of ways, please write down. Number of ways of writing a number. Number of ways of writing a number. Number of ways of writing a number as a product of two factors. Only case 1 we discussed. As a product of two factors. As a product of two factors. What is case number 2? Case number 2 is unordered pair. Case number 2. Case number 2. It is an unordered pair. Tomorrow morning class, don't miss it, sir. Each and every class of mine will be full concepts. Unordered pair. What do you mean by unordered pair? Ordering does not matter. That means reverse is equal. Ordering does not matter. Unequal, which are not equal. Unordered pair. Ordering is not requires. Reverse cases you can duplicate it. When the unordered pair is used, if the variables are not present in the question, if the variables are not present in the question, if the variables are not present in the question, make use of unordered pair. This is an extremely important key point. Variables are present in the question, use ordered pair. Variables are not present in the question, use unordered pair. In that one, case 2a, there are two cases that will come. That also we will discuss. If the given number is a non-perfect square, if the given number is a non-perfect square, given number is a non-perfect square. Case 2a, given number is a non-perfect square. Suppose if I take 12, is 12 a perfect square? No, it lies between two perfect squares, 3 square and 4 square. So it is nothing but 1 into 12, 2 into 6 and 3 into 4. Should I write the reverse? 12 into 1, reverse should not be written. 6 into 2, it cannot be written. 4 into 3, it cannot be written. Half of the cases are eliminated. If half of the cases are eliminated, what will be the answer? Number of factors by 2. Number of factors by 2. Please write down. Why it became by 2? Because half of the cases will be eliminated. Unordered pair a comma b is equivalent to b comma a. If the number is a non-perfect square, if the number is a non-perfect square, then it is number of factors by 2. Half of the cases are eliminated. Then case 2b. Not a single doubt you will get it in my class. Case 2b. Number, it is a perfect square. Number, it is a perfect square. Number, it is a perfect square. This will be number of, first write down, in the next full paper I will discuss. Number of factors plus 1 by 2. If root 10 into root 10 is included, if I include root 10 into root 10, it is number of factors plus 1 by 2, or otherwise number of factors minus 1 by 2. Write down as it is. Then in the full slide, I will take an example and I'll clearly make you understand why number of factors plus 1 by 2 came and number of factors minus 1 by 2 came. Remember, if it is an unordered pair, if it is an unordered pair, if the number is a non-perfect square, it is number of factors by 2. If it is a perfect square, if it is a perfect square, two cases will come. Number of factors plus 1 by 2, number of factors minus 1 by 2. Number of factors minus 1 by 2. I will discuss in detail case number 2b in the next slide. Case number 2b in the next slide. Now see here. Case 2b. Now we will take a lot of examples to make us understand if n number is a perfect square. If a number is a perfect square. If a number is a perfect square. 36 it is there. 36 is 1 into 36, 2 into 18, 3 into 12, 4 into 9, and 6 into 6. 6 into 6. Reverse cannot be written. 36, it is nothing but 4 into 9. 4 is nothing but 2 square into 3 square. So totally, how many factors we got? Number of factors. It is nothing but 3 into 3. 9 factors we got. Number of factors we got 9. Totally, how many cases we got? 1, 2, 3, 4, 5. What is this case? This is nothing but root 36 into root 36. Are you all with me? Root 36 into root 36. If I include that root 36 into 36, answer is nothing but number of factors plus 1 by 2. 9 divided by 2. Number of ways can never be in a decimal value. 9 plus 1, 10. 10 divided by 2, 5. If I include this one, then it is, if I include this one, then it is a number of factors plus 1 by 2. Include this one. Root 10 into root 10. If I include it, it is number. If I exclude it, how many ways we got? 4. I hope it is clear. Number of ways minus 1 by 2. 9 minus 1 by 2. These excluded. These nothing but excluded. Excluded. Sir, when to include, when to exclude? If the question contains distinct word, distinct means different. If the question contains distinct word. Use these number of factors minus 1 by 2. 6 into 6. 6 into 6 both are same. Distinct means two different numbers product should be equivalent to the given number. Here same number product is equivalent to the number. If the question contains distinct, use these word. Number of factors minus 1 by 2. If the question does not contain distinct, use this concept number of factors plus 1 by 2. I will put a table here so that it will be crystal clear to you. In an ordered pair, it does not matter whether the number is a perfect square or not. Answer is equivalent to number of factors. Answer is equivalent to number of factors. Only when it is an unordered pair. For a perfect square, it is number of factors plus 1 by 2. If root 10 into root 10 included, otherwise it is excluded. What I'll do is, I will give a table. Number of ways. Listen carefully, sir. Number of ways of writing a number as a product of two factors. In permutation and combination, we'll discuss product of three factors and so on. Number of ways of writing it as a product of two factors, two ways. One is ordered pair. Ordered pair. When the ordered pair, when variables are present in the question. If variables are present in the question, then it is an ordered pair. What will be the answer? Answer is nothing but equivalent to number of factors. Answer is nothing but number of factors. Answer is nothing but number of factors, right? In an unordered pair, what is unordered pair? Variables are not present in the question. Variables are not present in the question. Here, two cases will come. N is a perfect square. N is a non-perfect square. N is a non-perfect square. Non-perfect square, it is simple. Number of factors divided by 2. Number of factors divided by 2. Here two more cases will come. Number of factors plus 1 by 2. Number of factors minus 1 by 2. Minus 1 by 2. I hope this flowchart is extremely clear to you. When it is used, plus 1 by 2, plus these distinct word is there in the question. Distinct word is there in the question. Answer is number of factors minus 1 by 2. If the distinct word is not present in the question, answer is number of factors plus 1 by 2. I hope this idea it is clear. This clear? Right after this class is over, kindly watch the class again. Make your self-notes. Self-notes is always the best notes because you will write down in the way that you have understood thing. I hope it is clear. Now, we will solve a few problems so that you will understand. In how many ways can the below numbers be written? Can the below numbers be written as a product of two factors? As a product of two factors. As a product of two factors. In how many ways? In how many ways can the below numbers be written as a product of two factors? Very easy question. Suppose first one 72. First one 72. 72. Are the variables present in the question? Variables are not present in the question. Is 72 a perfect square? No, it is a non-perfect square. If it is a non-perfect square, 72 it is 2 cube into 3 square, 8 into 9. So answer is number of factors divided by 2. Tomorrow's class, you will understand the power of these concepts. These 4 into 3 divided by 2. Answer is 6. In how many ways can you write 72 as a product of two factors? Variables are not present in the question. If variables are not present in the question, it is an unordered pair. And if it is a non-perfect square, answer is number of factors by 2. Suppose if it is 100, it is a perfect square. If it is a perfect square, 100 is nothing but 2 square into 5 square. Are you with me? 2 square into 5 square. So what will be the answer? If it is a perfect square will be number of factors. By default it is number of factors plus 1 by 2. 9 plus 1 by 2. 10 by 2. It is nothing but 5. It is nothing but 5. By default, is the word distinct present in the question? Distinct, it is not present in the question. If a distinct word is present in the question, I would have used the number of factors minus 1 by 2. Since the variables are not present in the question, it is an unordered pair. Because it is a non-perfect square, it is a number of factors by 2. If it is a perfect square, number of factors plus 1 by 2. I hope the idea it is clear. Suppose if the question is, for example, in how many ways can 400 be written as? In how many ways can 400 be written as product of two distinct factors? Product of two distinct factors. Product of two distinct factors. Product of two distinct factors. Now see here. This is a very good question, sir. It will give an understanding to our concept. First of all, variables are not present in the question. Variables are not present in the question. If variables are not present in the question, then it is an unordered pair. Then it is an unordered pair. Unordered pair. I hope you are all there with me. If it is an unordered pair, 400, it is a perfect square. Perfect square. 400 is 20 square. Product of two distinct factors. Distinct question is there. Distinct, if word is there, answer would be number of factors minus 1 by 2. Number of factors minus 1 by 2. 400 is nothing but 20 square. 20 square is 2 square into 5 whole square. 2 power 4 into 5 square. Factors will be 5 into 3 minus 1 by 2. Answer is 7. I hope you got the clarity on what is an ordered pair, what is an unordered pair.